Hey guys, welcome to Michelle's STEM Journey. I am Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2013, 10A, Problem 18, and it deals with geometry. I hope you all enjoy this video and let's get started. The problem states, let point A, which has the coordinates of 0, 0, B, which has the coordinates of 1, 2, C, which has the coordinates of 33, and D, which has the coordinates of 4, 0. Quadrilateral ABCD is cut into equal area pieces by a line passing through A. This line intersects CD at point P over Q and then R over S, where these fractions are in lowest terms. What is P plus Q plus R plus S? So firstly, I drew out the quadrilateral and I named the points. And in the question, it says that the line that cuts the quadrilateral ABCD into equal pieces intersects CD at point P over Q and then R over S. So I'm just going to let that point be E, so it is right here. And so that means that triangle ADE and the trapezoid ABC and E, they have the same area. And so to get this problem started, I think that we should first find out the area of the whole quadrilateral ABCD. And from there on, we can find out the individual areas and go from there. So to find out the area of the quadrilateral, there are many methods that you can use, but I am just going to draw the perpendicular lines from B and C to the x-axis to divide the quadrilateral into triangles and trapezoids, as I did already right here. So it's right here and then this. So if you look at it, then we see that we have a big trapezoid. So this big one. And then we have a smaller trapezoid. And then we have a triangle at the bottom. So because we know the coordinates of the 4 points, then that means that we know most of or all of the lengths that we need to solve for the area. So starting off with this length, we know that it is 3 because it reaches point C and C has an x-axis of 30. Then I'm just going to quickly label all the lengths. Okay, so now we know all the lengths, and that means that we can find out the area of the whole trapezoid. So it would be the top base plus the bottom base times the height divided by 2. So it would be 3 plus 4. You multiply that by 3, which is the height, and then you divide this by 2. So this is the big trapezoid. So it would give us 21 over 2. And then to find out the area of the small trapezoid, it would be same formula. It would be 1 plus 3 times 1 over 2, which is 2. So the area of the small trapezoid is 2. And then the area of the small triangle is 1 times 2 over 2, which is 1. So the area of that triangle is 1. And then so we can just do 21 over 2 minus 2 minus 1, which would give us 15 over 2. And so now we know that quadrilateral ABCD has an area of 15 over 2. And so therefore each equal piece that the line separates ABCD into must have an area of 15 over 4. So you just divide this by 2. And so to solve this problem, it just wants us to find out the coordinates of point E. And I'm going to do that by drawing a line that connects E to the x-axis, and it forms a right angle, so it is perpendicular to that line. And so we know that triangle AED. That has an area of 15 over 4. So base times height over 2 would equal to 15 over 4 for the triangle AED. And furthermore, we know that B equals 4 because it says right here, that's the base, and base equals 4. So we can just substitute that, which would be 4 times h over 2 equal to 15 over 4, and we can solve for h. So h would be equal to 15 over 8. And that is perfect because now we know that this segment right here, the height of the triangle AED is equal to 15 over 8. And so that means that point E has a y-coordinate of 15 over 8. And now we just need to find out the x-coordinate. Okay, and if we notice here, point E is on line CE. And because we already know the y-coordinate of point E, then that means that if we can find the formula for line CE, then all we have to do is plug in the y-coordinate into that line to find out the x-coordinate value. So first we need to find out the equation for line CD. So first we need to find out the slope for that. Well, we use m to indicate the slope, and the slope is, the formula for slope would be y2 minus y1 over x2 minus x1. So in that case, it would be 3 minus 0. So 3 minus 0 over 3 minus 4, which is negative 1. So the slope would be negative 3. So there are many methods to find out the equation for a line, but we're just going to use the point slope form, and that is y minus y sub 1 is equal to the slope m times the quantity of x minus x sub 1. So in this case, we know we can just use the coordinate for D, and so the y-coordinate for D is 0, so it'd be y minus 0 is equal to the slope, which is negative 3 times x minus 4. Simplifying this, we would get y equals negative 3x plus 12. And so now we know the equation for line CD. And now all we have to do is plug in 15 over 8 into this equation as y. So we would get negative 3x plus 12 is equal to 15 over 8. And then simplifying this, we would get x equals 27 over 8. And so there we have it. We have both the x-coordinate and the y-coordinate for point E. And all we have to do is add up the numbers. So 27 plus 8 plus 15 plus 8. This would give us 58. And so therefore the answer is B, 58.